All right, now we are on to page 2. So just a little thing here. We will be having a calculator and non-calculator portion on the test, and you will be expected to show work because you will not have your calculator for this section of the test, okay? So with that, you will have your toolkit, and you will need to know your points. So the first one is a square root function. So that means I will be using these points for my x's. And when I take the square root of these numbers, these will be my y values. When you do graph B, you have a cube root function. So these are the numbers we're going to use. And then here are their cube roots. And then when we do the absolute value on C, these are the x values we will use. And here are their y values because we're taking the absolute value of the x's, and that turns everything positive. All right, D is our line, so we'll deal with D when we get to D. All right, let's talk about our transformations. So I have a right 3 and an up 7. I do not have a stretch or a compress or a flip. There is nothing here that I need to change. So I can just take these points and move them right 3, up 7. So I'm going to start with 0, 0 and go right 3, up 7. And then from here, this x, I'm going to go right 1, up 1. I'm going to go right 4, up 2. And then there's not really room for 9, 3, so I'm going to connect. An arrow is only on the right side. This side stays a dot. Since I have to answer domain and range questions, I'm going to mark where it starts, where it stops. So my smallest x to biggest x, and my smallest y to my biggest y. All right, on B, we do have a flip. So I will be changing all of these y values. But then I also have left 2, down 5. But let's take care of the flip. So all of these y's are going to flip to their opposite values. So -2 becomes 2, -1 becomes 1. I'm just going to change them all, cross out the old y's. And I'm going to start with my 0, 0. And 0, 0 is going to move left 2, down 5. And then this will become my new starting point. So from here, I'm going to go left 8 and up 2. And I'm going to go left 1, up 1. So taking care of these points here. And then I'm going to go right 1, down 1. And then right 8, down 2. So when I'm done connecting, it's going to look like this. All right, here I'm asking in this problem, if x is -3, what's my y value? And that happens to be, put a highlighting point on there, right here. So it's going to be -4. And the other one is saying if y is -7, then what's x? So if I go to y is -7, then my x is this value right here, which is a 6. So let's circle the final answers there. All right, next one. On C, we have a flip and a stretch from this -3, so I will be changing these values. But I also have a right 4, so I'm going to multiply all these y values by -3. And again, I'm just going to start with my 0, 0, and I'm going to go right 4. And then from here, I'll get the other points. So I'm going to go left 2, down 6. I'm going to go left 1, down 3. I'm going to go right 1, down 3. And I'm going to go right 2, down 6. And then this is our V shape. All right, asking about domain and range again. So I've got an arrow over here, negative infinity. This one is positive negative infinity. And the dot, the orange dot right there is 4, 0. So when I do my smallest x to biggest x, I've got infinities. When I do my range, my small range is negative infinity. My biggest range is 0. All right, last one, piecewise functions. So the first thing I'm going to deal with is this boundary wall, this invisible wall. So it's right here at 1. When I graph the 2x plus 4, it's to be to the left of the wall. And then when I graph the -1, it'll be the right on the wall. So I'm actually going to graph the -1 to the right of the wall first. So here's -1. All the y values are 1. Arrow on this side. And I will do a closed dot because it's underlined right there. And then on the other one, I'm going to have a y-intercept. So b is by itself. I'll be beginning at 4. Here's my 4. I'll have a rise and run of 2/1, which will be going uphill. And I'm just going to go up 2/1 or down 2/1. And then I'm going to have a line that goes like this. This will be an open dot though. And I'm going to answer my questions. So my questions I can use one of two ways. I can use the picture or I can use the equations. If you use the picture, then it's saying if x is -3, what's your y value? Which turns out to be this point right there. So it's -2. You can also go to this function because -3 is less than this one here, and I can put in the -3 and get -2 that way. The other option, so for the next one, if I go to x is 7, what's my y value? And it's -1. So again, you can use the picture. You can also go up to the equation, and since 7 fits here, my answer is -1. No math to do. All right, there is your graphing. Let's go into writing equations. So we're going to write the equation. We need to know that this is a square root. So, and from 0, 0, I just went left 3. So I write left 3 by putting x plus 3. It never moved up and down, so if you want to put a number, you could put an up and down. But now what I want to do is see if I can just figure out a by the picture. So you can figure out a by the picture. If from wherever 0, 0 ended up, if you go right 1, how many do you go down? And I know for a fact that I went down 1. So I went down 1, which means I'll put a -1 here. And then there goes my y. All right, on the next one, it happens to be another square root function. They actually got it a little bit set up here, but let's say they didn't do that. My starting point went right 5. I can see that by this. So I went right 5, but I didn't go up or down. So that's where I can start my function as x minus 5 says right 5. It didn't go up or down, but what I can't see is what a is because I don't know how many they went over. When they went over 1, how much they went up. So I will be figuring out what a is, and I'm going to figure out what a is by taking this point and putting 14 in for x and 2 in for y. So 2 in for y, 14 in for x. And then I'm going to solve for a. It's one type of a. I just need to get a alone. But what I'm going to do first is get this a little more simplified. So 14 take away 5 is 9. The square root of 9 is 3. And now to get a alone, I divide by 3. And so a ends up being 2/3. And that's all I had to do on this one was just say what a is. All right, let's go to domains. So we've got our 2 big domain issues. One issue is when x is inside a square root. And since we've moved into rational exponents, that also means it's inside exponents that are the 1/2 power. And we just can't take the square root of a negative number. So if you remember, we got to take whatever's inside the check mark and set it greater than or equal to 0. Our other issue is if x is in a denominator, and you just have to take the whole denominator, if you remember, and say that it can't equal 0. All All right, so, and if you don't have any of those issues, then it's just anything you want, all real numbers. So first one, I notice it's to a 1/2 power. That's just like a square root. So I will take what's inside the radical and set it greater than or equal to 0. I'm going to subtract the 3 over. And then since I do need to write my answer in an interval notation, it helps me if I put this on another number line, close circle, and greater than -3 goes this way, which means I'll have an infinity. And when I do my interval notation, I can say from -3 to infinity with a bracket around -3. All right, next one is a very noticeable square root. So same idea. I'm going to take what's inside the square root, greater than or equal to 0, subtract the 5, put it on a number line. So again, here's -5, close circle, going to the right. Right is a positive infinity, so I'll have from -infinity or -5 to infinity. And there's my interval notation. All right, C, if you notice, it's actually a cube root, and cube roots are fine. I can do the cube root of any number I want. So here my domain is just going to be all real numbers, or I could do the infinities, whichever you prefer. D, I have another square root. So whatever's inside the square root has to be greater than or equal to 0. So I'm going to add the 49. And then I'm going to square root 49 for 7 and -7. Because I have two answers and I have an alligator, I'm going to put a picture to this so I can see where my alligator's happy. So here's my number line. Here's the 0. X squared minus 49 is a regular u. And so I've got -7 here and 7 here. And here I just want the part of the u that is above the flat line. So that's here and here, which gives me -infinity, infinity. So when I write where my alligator's happy, he's happy from -infinity to -7, close circle, so a bracket, and then from 7 to infinity. Okay, there is my answer for D. Let's move on to E. So E and F, we have stuff in the denominator, which just means this denominator cannot be worth 0. So if I add the 1, I just can't pick 1. So as far as the number line goes, 1 would be an open circle because I don't want to include it. But I can include everything else. So I'll go this way and this way, infinity, -infinity. So my alligator will be happy in two areas, from -infinity to 1, parentheses on both, and then again from 1 to infinity. All right, last one for domain and range. All right, so I'm going to take what's inside the denominator, can't equal 0, add the 25 over, square root, so x can't be 5 and -5. It can be everything else, but not 5 or -5. So here's -5, open circle, 5, open circle, and that means it can be here with this arrow, and between those numbers to the right of the 5 with an infinity sign there. And now my alligator's happy in 3 spots. So I've got -infinity to -5, -5 to 5, and 5 to infinity. And then here is my answer for F. All right, I don't know what this is. Ignore that. All right, the graph of this is shown below. Oh, and actually, you know what? That was a whole nother page. So I think what I'm going to do, let's go ahead and do this page in this video, because I think the next part will take longer. So let's go ahead and keep this in the video. Actually, no. Pause, take it back. This will be the end of that video.